All right, you are welcome again. Today, we're going to take something very serious, which is 7 ways to prove or to show that any number raised to power 0 is equal to 1. You know, there are some theories and hypotheses that we receive in school, but we may not have seen or gotten a satisfactory answer to those theories. So I'm here to answer one of them. Why is it that any number raised to power 0 is 1? So I want to show you 7 ways to prove it. And you are not going to learn just 7 ways to prove that any number raised to power 0 is 1. But there are some things, vital things you are going to learn along the line. So please, I want you to watch this video to the end. Honestly, you're going to learn a lot in this video. Not just 7 ways to prove it, but there are some kind of theories and some kind of new things, very vital, that you are going to learn. Okay? Now let's go. Please watch this patiently. Most especially number 6 and number 7 is very important. Okay? Now let's go. Number 1 way. You know, we have something like any number raised to power 0. Okay? Now let's say something like x raised to power a number. You know, this is how to write exponent. Okay? Now, if you want to find the answer to this x raised to power n, you can actually say that this answer is going to give you x raised to power n plus 1 all over x. Hello? To find this exponent, x raised to power n, what is it going to give you? It's going to give you x raised to power n plus 1 all over x. Now, let's see, for instance, let me try to see whether this formula is true. Now, for instance, we have 8 raised to power 7. Let's pick a big number and then also a small number to show whether it's true. 8 raised to power 7. That means it's going to give us 8 raised to power 7 plus 1 all over 8. Hello? It's going to give us 8 raised to power 7 plus 1. That is the exponent 7 plus 1 all over 8. So 7 plus 1 in the exponent is going to give us 8. So we have 8 raised to power 8 all over 8. So 8 raised to power 8, when you punch it in your calculator, it's going to give us 16,777,216. Then we have all over 8. So when you say 16,777,216 divided by 8, punch it in your calculator, it's going to give us 2,097,152. Is that true? Yes. Okay, I want you to punch in your calculator direct without following this method. 8 raised to power 7. Let's see what it will give you. When you punch it in your calculator, 8 raised to power 7, I am very sure it's going to give you 2,097,152. So you can see that you can go directly or you can use this formula to find it. Okay, now let me also use small number to see whether it's true. When you say 3 raised to power 4, what does it mean, or what is it? So that means you're going to have 3 times 3 times 3 times 3 into 4 places. Okay, so when you say 3 times 3, it's going to give us 9. 9 times 3 is going to give us 27. So 27 times 3 is going to give us 81. Is that true? Yes. Now hold it. So that is to say that 3 raised to power 4 is equal to 81. Is that true? Yes. Okay, now let's go. Let's use the same method here, or this formula, to find 3 raised to power 4. You know, we have the method x raised to power n is equal to x raised to power n plus 1 all over x. Okay, so here that means going to have 3 raised to power 4 plus 1 all over 3. So here we have 3 raised to power 4 plus 1 is equal to 5. That means we have 3 raised to power 5 all over 3. Okay, so 3 raised to power 5, what is it? That means going to have 3 times 3 times 3 times 3 times 3 into 5 places. Okay, so it's going to give us 243. So 3 raised to power 5 is equal to 243 divided by what? By 3. So when you divide it by 3, it's going to give us 81. So this is the formula for finding exponent. You get it right? Okay. Now, I want to use this formula to establish a fact. Okay. Now, let's go. What is x raised to power 0? What is what? X raised to power 0. That means we're going to say x raised to power 0 plus 1 all over x. And then 0 plus 1 is what? 1. So that means we're going to have x raised to power 1 all over x. So x raised to power 1 is what? X. So x all over x is equal to what? 1. Hello. So we have used this to establish a fact that x raised to power 0 is equal to what? 1. Not only a number, even your name raised to power 0 is equal to what? 1. Yes, anything except 0. Except 0 raised to power 0. So every other thing, every other number raised to power 0 is equal to 1. Now maybe you are confused. I just use a letter. Let's use a number. So 2 raised to power 0, what is it? 2 raised to power 0. So using our method or our formula, we're going to say that 2 raised to power 0 is equal to 2 raised to power 0 plus 1 all over 2. So this numerator, 2 raised to power 0 plus 1. 0 plus 1 is equal to what? 1. So that means we're going to have 2 raised to power 1 all over 2. So 2 raised to power 1 is what? 2. 2 divided by 2 is equal to 1. So therefore, any number raised to power 0 is equal to 1. Have used this to establish this fact. Okay, now let me also show you the inverse of this formula that I just gave you. Okay, now we have x raised to power n minus 1. Hello, x raised to power n minus 1 is the same as x raised to power n all over x. Is that true? Please pay attention. X raised to power n minus 1 is the same as x raised to power n all over x. Now, what if the n is 1? That means we're going to have x raised to power 1 minus 1, which is equal to 0. Okay, in the other side, that means we're going to have x raised to power 1 all over x. So x raised to power 1 is what? X. X divided by x is equal to 1. So therefore, x raised to power 0 is equal to 1. Any number raised to power 0 is equal to 1. Number 1. Okay, now let's go. Number 2 way. The number 2 way to show that any number raised to power 0 is equal to 1. Okay, now let's go. You know, when they're talking about exponents, let's take a look at this. X raised to power a times x raised to power b. You know, in the law of indices, that means we are going to simply say x raised to power a plus b. Is that true? Yes, you're going to add the what? The exponent. Since the base is the same, so we'll simply add the what? The exponent. Now let's go. What if one of these exponents is negative? What if one of these exponents is what? Is negative. For instance, we have x raised to power a times x raised to power minus b. Let's say b is negative. That means we have raised to power what? Minus b. So what is it going to give us? That means we're going to have x raised to power a minus b. Is that true? Yes. Is that true? Yes. Now let's go again. What if the exponents are the same? Now, you know, they are negative. One is negative. And then another condition, what if they are the same and one is still negative? how it's going to be. So that means we're going to have x raised to power a times x raised to power minus a. What is it going to give you? We're going to have x raised to power a minus a. So x raised to power a minus a is equal to what? 0. That means we're going to have x raised to power 0. So x raised to power 0, what is it? That is what we don't know. And I want to show you the second way to prove it. And I've established a fact, right? Now, follow me gradually. We said that x raised to power a times x raised to power minus b. What is it going to give us? We're going to have x raised to power a times. In the law of indices, when you have x raised to power minus b, this minus exponent minus b, we're going to have 1 all over x raised to power b. Is that true? Yes. So that means we're going to have x raised to power a times 1 all over x raised to power b. So when you multiply this, it's going to give you x raised to power a all over x raised to power b. Is that true? Yes. Now let's also go again. When you have x raised to power a times x raised to power minus a, what is it going to give you? When we solved initially from above, we said that we found out that it is equal to what? 0. Is that true? Yes. Now let's see what is going to give us. So here we're going to have x raised to power a times, this x raised to power minus a can be written as 1 all over x raised to power a. Is that true? Yes. That means we have x raised to power a times 1 all over x raised to power a. So when you multiply these together, we're going to have x raised to power a all over x raised to power a. So x raised to power a, they are the same, right? When they divide each other, they are the same thing. It's going to give you what? 1. Hello? X raised to power a divided by x raised to power a. I think it's going to give you what? 1. Okay, that means that any number n raised to power 0 is equal to what? 1. Is that true? Okay, I just use letters to explain this. Let's go further to use number, okay? Maybe from there you understand better. Let's use a number. We have something like 3 raised to power 2 times 3 raised to power 3. What is it going to give us? It's going to give us 3 raised to power 2 plus 3. Okay? So when you add this together, it's going to give us 3 raised to power 5. Okay? And then 3 raised to power 5 is equal to 243. Okay? Yes. Now let's go again. What if one of the exponent is negative? Maybe for instance, we have 3 raised to power 2 times 3 raised to power minus 3. What is going to give us? That is going to have 3 raised to power 2 minus 3. Okay, so when you say 2 minus 3, it's going to give us minus 1. So here we have 3 raised to power minus 1. Is that true? Yes. Now, what if the exponents are the same? One of them is negative and then both of them are the same. Now, that means going to have something like 3 raised to power 3 times 3 raised to power minus 3. Hello? So that means going to have 3 raised to power 3 minus 3. So 3 minus 3 in the exponent is equal to what? 0. So 3 raised to power 0 is equal to what? That is what we don't know. So we want to prove this. Okay? Now let's solve this. So when you say 3 raised to power 3 times 3 raised to power minus 3, initially going to give you 3 raised to power 0. Okay? Now let's solve it. You can simply say 3 raised to power 3 times, this 3 raised to power minus 3 is going to give you 1 all over 3 raised to power 3. Is that true? Yes. Now when you multiply these together, it's going to give you 3 raised to power 3 all over 3 raised to power 3. So 3 raised to power 3 is 27. All over 3 raised to power 3 again is what? 27. So 27 divided by 27 is equal to 1. So with this, I've shown you the second way to prove that any number raised to power 0 is equal to 1. Now let's go. Number 3 way to show that any number raised to power 0 is equal to 1. Now let's take a look at this. We have x raised to power a plus b. You know, this, if you want to expand this, you can simply say that this is x raised to power a times x raised to power b. Is that true? Yes. Okay, now let's ask a question. What if a is equal to 0? What if a is equal to 0? That means we're going to have x raised to power 0 plus b. You know, when you say 0 plus b is equal to what? B. So that means we're going to have x raised to power b. Is that true? Yes, okay. But what if we want to expand it? That means we're going to have x raised to power 0 times x raised to power b. And then you know that this is equal to x raised to power b. But we don't know x raised to power 0. So what will be the value for this x raised to power 0 such that when it multiplies this x raised to power b is going to give us x raised to power b? Hello. You know, we have solved from the initial where we say x raised to power 0 plus b is equal to x raised to power b, right? Good. So we want to expand it. So when we expand it, we're going to have x raised to power 0 times x raised to power b. But we don't know x raised to power 0, which is any number raised to power 0. So here we say that x raised to power 0 times x raised to power b is equal to x raised to power b. So what is the value for this x raised to power 0 such that when it multiplies this x raised to power b is going to give us x raised to power b? So you discover that x raised to power 0 is equal to 1. So that when this 1 multiplied by x raised to power b is going to give us x raised to power b. So from here, or from this little illustration, you can see that any number raised to power 0 is equal to 1. All right? Yes. Now let's go. Number 4. The fourth way to show that any number raised to power 0 is equal to 1. Now let's ask a question. What does it mean to raise a number to a certain power? You know, that means that you multiply that number by itself a certain number of times. For instance, when you have 4 raised to power 3, that is to say 4 multiplies itself 3 times. That is, you're going to say 4 times 4 times 4. 4 multiplying itself into 3 times. Okay? Now let's take a look at this. You have 2 raised to power 6. That is to say 2 multiply itself into 6 places, which is going to give us 2 times 2 times 2 times 2 times 2 times 2 equal to 64. And then when you say 2 raised to power 5, that is 2 times 2 times 2 times 2 times 2, which is equal to 32. And then 2 raised to power 4, that is 2 multiply itself into 4 places, which is going to give you 16. And then 2 raised to power 3 is going to give us 2 times 2 times 2, which is equal to 8. And then 2 raised to power 2 is equal to 2 times 2, which is equal to 4. And then 2 raised to power 1 is 2, equal to what? 2. All right? Yes. Now, you see this? Okay, let's ask a question. But how can we get from 2 raised to power 1 to 2 raised to power 0? Yes, how can we get from 2 raised to power 1 to 2 raised to power 0? Now let's take a look at the pattern. Let's take a look at the pattern. So you see that the exponent, this 2 raised to power 6, 2 raised to power 5, being the exponent, is being reduced by 1. You get it? So it's being reduced by 1. Now, if you reduce this by 1, That is how we get 2 raised to power 6. Reduce the exponent by 1, it's going to give you 2 raised to power 5. Reduce the exponent by 1, going to give you 2 raised to power 4. Reduce the exponent again by 1, 2 raised to power 3. Reduce it again, 2 raised to power 2. Reduce it again, 2 raised to power 1. Reduce it again, 2 raised to power 0. Then, how do we get, or what does the pattern, the answer, what pattern does it follow? Okay, the pattern that it follows is this. We're going to say the number before the reduction divided by 2 is going to give you the answer. Now look at it. What I'm trying to say is this. We have 2 raised to power 6. We reduce it by 1. It gives us what? 2 raised to power 5. So the answer is going to give us 64 divided by 2. It's going to give you 32. We also say 2 raised to power 5. Reduce the exponent by 1. Going to give you 2 raised to power 4. Then the answer is going to give you 32 divided by 2 equal to 16. Also, 2 raised to power 4. Reduce the exponent by 1. Going to give you 2 raised to power 3. And then the answer is going to give you 16 divided by 2 equal to 8. Also, 2 raised to power 3. Reduce the exponent by 1, you're going to have 2 raised to power 2. The answer is going to give you 8 divided by 2. And then we'll reduce again, 2 raised to power 2, reduce the exponent by 1, going to give you 2 raised to power 1. The answer is going to give you 4 divided by 2, which is equal to 2. Now, finally, 2 raised to power 1, reduce the exponent by 1, going to have 2 raised to power 0. So the answer, what is it going to give you? It's going to give you 2 divided by 2 equal to 1. Hello? Yes. That is what we are trying to say. Now, maybe you say that this pattern only works for 2. You can choose any number and try it. Now, let me choose another number, 5. So when you say 5 raised to power 5, it's going to give you 3,125. Reduce the exponent by 1 is going to give you 5 raised to power 4. So the answer is going to give you 3,125 divided by 5. It's going to give you 625. Again, reduce the exponent 4 by 1. That means you're going to have 5 raised to power 3. Then go back. The answer is 625 divided by 5. Going to give you 125. Also, reduce the exponent by 1 again. That means you're going to have 5 raised to power 2. Then the answer is going to give you 125 divided by 5, which is equal to 25. Also, 5 raised to power 2, reduce the exponent by 1, going to have 5 raised to power 1. So the answer is going to give you 25 divided by 5, which is equal to 5. Then lastly, reduce the exponent by 1. That means you're going to have 5 raised to power 0. The answer is going to give you 5 divided by 5, which is equal to 1. So with this example, or with this illustration, with this pattern, we are able to show that any number raised to power 0 is equal to 1 following this pattern. Yes, any number raised to power 0 is equal to 1 except 0 raised to power 0. Okay, now let's go. Number 5 way to show that any number raised to power 0 is equal to 1. Let's take a look at this. We have 3 raised to power 1. You know, it's the same thing as saying 3, right? Yes. And then 3 raised to power 2. That is 3 multiply itself into 2 places, okay? So we have 3 times 3, which is equal to 9. And then 3 raised to power 3. That is 3 multiply itself into 3 places, okay? So we're going to have 3 times 3 times 3, which is equal to 27. Now, 3 raised to power 4. We have 3 times 3 times 3 times 3, which is equal to 81. And then 3 raised to power 5. We have 3 times 3 times 3 times 3 times 3, which is equal to 243. Okay? Yes. Now, let's write this again. You know, this thing we just wrote like this is the same thing as saying 3 raised to power 5. You know, it's still the same thing as saying 3 times 3 times 3 times 3 times 3 times 1. It's going to give you what? The same 243. Is that true? Yes. And then here we have 3 raised to power 4. That means we are going to remove 1 3. Is that true? So when you cancel out or when you remove 1 3, that means you're going to have 3 times 3 times 3 times 3 times 1, which is equal to 81. Now 3 raised to power 3. You remove 1 3 again. We have 3 times 3 times 3 times 1. So we have 27. Reduce the exponents. That means we're going to have 3 raised to power 2, right? And then that means we're going to cancel 1 3. So we're going to have 3 times 3 times 1, which is equal to 9. And then 3 raised to power 1. That means we're going to remove 1 3 again. That means we're going to have 3 times 1 equal to 3. Now 3 raised to power 0. That means still going to remove 1 3 again. So when you remove 1 3 again, you're going to have 1. So 3 raised to power 0 is equal to 1. So following this pattern, please pay attention to this. It's very simple. This is just logical, okay? By reasoning, you'll be able to show, using this method, that any number raised to power 0 is equal to 1. Okay? You can call this by reduction. By what? By reduction method. Okay? Now let's go. Number 6. I want you to pay attention to this number very well. Pay attention to this very well. Okay? Now, x raised to power n. What does it mean? You know, x raised to power n. The answer is the number of ways you can arrange set of n elements from 1 to x. Hello? Yeah, this is, maybe you can call it arrangement method. So we say that x raised to power n. What does it mean? It's talking about ways of arrangement. The total number of ways you can arrange set of n elements. You know, the n, the exponent, n elements from 1 to x. You know, x is a number, right? So starting from 1 to x. Number of ways you can arrange set of n elements from 1 to x. Now, let me use number and explain. So when we have something like 2 raised to power 3, the answer is what? 8. So this 8 means that we have 8 number of ways you can arrange set of 3 elements. Set of 3 elements, where each element can be either 1 or 2. We start from 1 to where? To 2, depending on the nature of the number base. Okay? Yes, now let me show you something. Maybe you didn't get it clearly. We have 2 raised to power 3 is equal to 8. So that means that 8 is the number of ways you can arrange sets of 3 elements. That is the exponent, 3 elements, set comprising 3 elements, where each element can be either 1 or 2. You get it right? Good. Now let me show you. We have 2 raised to power 3 is equal to 8, right? So we are going to form sets. And then the total number of sets that we can form is 8. And then this number of sets is having 3 elements. And then the element, each of the elements can be either 1 or 2. You know, you can use the idea of power set to understand this logic. Power set, if you have done set before, you can use the logic to understand what I'm trying to say here. Okay, now let's go. You know, we're going to form sets of 3 elements, of which each of the elements is either 1 or 2. Now the first set, we're going to have 1, 1, 1. The second set, we're going to have 1, 1, 2. The third set, 1, 2, 1. The fourth one, 1, 2, 2. The fifth one, 2, 1, 1. The sixth one, 2, 1, 2. The seventh, 2, 2, 1. The eighth, 2, 2, 2. There is no other set that you can form that is having 3 elements, that each of the elements can either be 1 or 2. No. You get what I'm saying? So these are the possible number of sets we can form. Or you can say arrangements you can get. All right? Yes, now let me show you another instance for you to understand better. We have 3 raised to power 2. 3 raised to power 2 is equal to what? 9. So that means we have 9 ways you can arrange sets of 2 elements. That is the power. 2 elements where each element is either 1, 2, or 3. We have 9 ways you can arrange set of 2 elements where each element is either 1, 2, or 3. Now let me show you. Let's go. Let me show you. We are going to form sets of 2 elements. Different sets that are having just 2 elements. And then those 2 elements is either 1, 2, or what? Or 3. Now let's go. The first one, we're going to have 1, 1. The second one, we're going to have 1, 2. The next one, we're going to have 1, 3. The next one, we're going to have 2, 1. The next one, we're going to have 2, 2. The next one, we're going to have 2, 3. The next one, we're going to have 3, 1. The next one, we're going to have 3, 2. The next one, we're going to have 3, 3. Full stop. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9. The total is 9. And there is no order that you can form. As having 2 elements, of which each of the elements is either 1, 2, or 3. So this is the idea, or another idea about exponents. Okay, now I have bring this to prove a point, okay, or to establish a fact. Now the question is this: what does 3 raised to power 0 mean? 3 raised to power 0, what does it mean? Hello? 3 raised to power 0, or any number raised to power 0, using the idea of arrangement or using the idea of set, what does it mean? So the answer is the number of ways you can arrange set of 0 elements where each element is either 1, 2, or 3. Is that clear? Yes. We say is the number of ways you can arrange set of 0 elements. We're going to have sets, and then those sets is going to have 0 number of elements, of which those elements is either 1, 2, or 3. Please pay attention. This is logical. This is logical, okay? Now, I want to ask you a question, a simple question. In how many ways can you arrange a pen, a book, and a pencil on a table such that no pen, no book, or pencil is on the table? That's just exactly what 3 raised to power 0 is all about. We're going to form sets, of which those set is having 0 elements. Is having what? 0 elements. And then those 0 elements is containing 1, 2, or 3. How possible is it? Now, it's just like you are being asked, how can you arrange a pen, a book, and a pencil on a table such that there is no book, there is no pen, and there is no pencil on the table. So the answer logically is 1. You only have one way to arrange a pen, a book, and a pencil on a table such that there is no pen, there is no book, and there is no pencil. Do you know the solution? Do not keep any of those items on the table. That is the only solution. Yes, that is the only arrangement. Hello. Do you understand what I'm trying to say? How many ways can you arrange a book, a pen, and a pencil on a table such that no book, no pen, and no pencil is on the table? You only have one way. What is the solution? Do not place any of those items on the table. So likewise, 3 raised to the power 0 is equal to 1 because you only have one set of elements of which the element doesn't contain either 1, 2, or 3. Yes, you get it? So by this reason, you can see that any number raised to the power 0 is equal to 1 by the illustration of arrangement of sets. Okay? Any number raised to the power 0 is equal to 1. All right, let's go. Let's take the last way to prove that any number raised to the power 0 is equal to 1. Number 7 way to prove or to show. Now, I can call this identity. Now, I want you to pay attention. In mathematics, there's what we call identity element. What is this identity element? We say that an identity element is an element with a certain operation such that when you combine it with any element in the set, it produces itself. Hello? When you have a set, that set may contain an identity element. So that identity element, when you pick it and perform a certain operation with any of the members of that set, it produces itself. Now, let me illustrate something. Let me show you something, what I'm trying to say. We have a set X such that X exists in real numbers. You get it? Okay, we have a set X such that X exists in real number. That is the list of all the real numbers 0, 1, 2, 3, 4, 5 continuously. Okay, now in this set there is an identity element in this set such that when you pick this element, identity element, and perform an operation to any of these member of this set, it will produce itself. For instance, 0 is an identity element. 0 plus any number, it produces itself. 0 plus 0 is 0. 0 plus 1, 1. 0 plus 2, 2. 0 plus 3, 3. 0 plus 100, 100. 0 plus 1 million, 1 million. It produces itself. We also have another identity element, 1. 1 times 0 is what? 0. 1 times 1, 1. 1 times 2, 2. 1 times 5, 5. 1 times 100, 100. 1 times 1 million, 1 million. It produces itself. Now, under identity element, we have different types or different kinds of identity. Okay, so we have what we call additive identity, and we have what we call multiplicative identity. So additive identity is what? Is 0. That is an element such that when you add it to any element in any set, or in this set particularly, this one I'm using for instance, it produces itself. You get it? So additive identity is 0. Multiplicative identity is 1. Okay? So, when you pick 1, multiply it with any of the elements, it produces itself. Okay? Now, we also have another example of identity. There's a formula in algebra, okay, that will say sine squared theta plus cos squared theta is equal to 1 for all the set of theta. Hello. For all the set of what? Theta. If theta is 20, when you say sine squared 20 plus cos squared 20 is going to give you 1. This is called an identity. If your theta is 90, when you say sine squared 90 plus cos squared 90, definitely is going to give you 1. This is an example of identity. Now let's go. What is a 0? 0 is a number. And then you discover that 0 is a symbol representing no entity. Hello. 0 is a number. Yes, is a number. And then in another sense, 0 is a symbol representing no entity. You get it? Now, when they say 0, 0 is a number. When they say nothing, nothing is not 0. Hello. But you can use 0 to represent nothing. But nothing is not 0. Now, listen to why I said that nothing is not 0. Using a set, when they say an empty set, it's talking about a set that is empty. But when this set contains 0, it's no longer empty. So nothing is not 0. Now, let me show you something. When you add nothing together, I'm not saying when you add 0 together. When you add nothing together, you will get 0. Hello? Why did you get 0? You get 0 because 0 is an additive identity. So if when you add nothing together and you get additive identity, that is to say, when you multiply nothing together, you are also going to get multiplicative identity. And I told you that 0 times 0 is different from nothing times nothing. Hello? You understand what I'm trying to say? Please, it is a simple logic. Don't be confused. 0 is a number. But I'm talking about nothing here. So when you add nothing together, you're going to have 0. And 0 is additive identity. So likewise, when you multiply nothing together, you're going to have 1 because 1 is multiplicative identity. So if when you add nothing together, you get additive identity, that is to say, when you multiply nothing together, you should also get multiplicative identity, which is equal to 1. Now let me show you what I'm trying to say. 3 raised to power 3 is what? 3 times 3 times 3. That is 3 multiplying itself into 3 places. It's going to give you 27. And then 3 raised to power 2. That is 3 multiply itself into how many places? 2 places. 3 times 3, which is equal to 9. And then 3 raised to power 1 is equal to what? 3. That is 3 multiply itself into 1. And then 3 raised to power 0. It means what? 3 multiply itself into what? 0 places. What does it mean? That is nothing multiplied by nothing. It's going to give you the multiplicative identity. And then the multiplicative identity is equal to 1. So therefore, 3 raised to power 0 is equal to 1. Finally, we have given 7 ways to prove, 7 ways to show that any number raised to power 0 is equal to 1, except 0 raised to power 0. Hello, except 0 raised to power 0. You get it? Yes. Please follow us in our YouTube channel if you are new, and if you have been following us, please keep watching. See you next time. Okay?